Okay, so continuing our path towards getting better at like HackerRank and stuff. So let's just keep going. I am exhausted, but we have to do this. We have to keep going, keep going, keep going. Okay. So just next one, I guess. Okay, whatever. So as normal, what we're trying to do here is obviously solve the problems, but also understand a different way of seeing questions and improve our reading comprehension and being able to map the question to the actual algorithm that we're trying to use. Okay. Hackerland University has the following grading policy. Every student receives a grade in the inclusive range from 0 to 100. Any grade less than 40 is a failing grade. Sam is a professor at the university and likes to round each student's grade according to these rules. If the difference between grade and the next multiple of 5 is less than 3, round grade up to the next multiple of 5. If the value of grade is less than 38, no rounding occurs, as the result will still be a failing grade, okay? So 84 goes up to a 85. It's less than 3, okay? This doesn't round, it's less than 38. Oh. Okay, 57, we do not round. So given the initial value of grades for each of Sam's and students, write code to automate the rounding process. So function description. Normally I would just like eagerly jump right in, but I'm just going to read through it because this is what we're also trying to do, is improve our reading comprehension with these kind of questions. So complete the function grading students for the following parameters. Int grades in is the grades before rounding. Returns an integer array, which is the grades after rounding. Okay. The first line contains a single integer n, the number of students. Okay. Each line okay. And now with HackerRank specifically, they do a really weird thing where the actual input is not the real input. So I have to take what they say here with a grain of salt, because I believe it is like this input that they're talking about that gets passed eventually to this function. So if you notice, they're going to say something like grading students is here, I get that, and then, okay. So I think we get the first one. So this input.strip. Now, this is the other thing with HackerRank, is normally with like leak code, we're not dealing with the input parameters. So okay, so strip, I'm guessing, just takes the first value in a argument string, right, and returns it. So that is the first n, so the first line containing integer n. So the grade count, and then we loop through it and then get each item, okay, and append that to a list. This will be an empty list, yeah. And then we pass that here, and then come here, and then do join. We're joining on the new line character, right? Oh. And then I'm not sure what that actually does. But, okay, so should we just start writing? So, the things that we want to do is, for grade in grades, like this. Do they want me to do it in place? Because I need to, let's see, return back. So I need to, result is going to be equal to an empty list, and then I will say if grade is less than, what was it, 38? If it's less than 38, no rounding occurs. So we can just do result.append grade, and then result is I know, like this. Okay, come on, man. There we go. And then continue like this. Else, see, how many rules did they say there is? I thought that they said 3 rules. So, less than 40 is failing. The difference next multiple is no less than 3, okay? So let's see, so this indicates we're gonna do something with a modulo, right? So I don't know exactly what I'm going to say, but something like, I don't know, rounding. Let's see. Fall off. Fall off is equal to grade modulo 5. And let's just walk through in our heads what this might mean. So if I have, let's say I have 41 here, right? What's going to happen? The modulo of 5 is going to be 1. So then if I have 44, the modulo is going to be 4. Okay. Now, obviously, I can think of a solution like this, but I'm trying to think of a more elegant solution. Like, if fall off is equal to, what do they want? If the difference between the grade and the next multiple is less than 3, round up. Okay. Is equal to, let's just say is equal to 1, right? Then result.append and then grade plus that 1, right? Oh wait, no, this is going to be if the, oh come on. If this is 4, because now we're at the 4. And so this is why I'm saying it's not a very elegant solution. Fall off is equal to 3. Then we do result append grade plus 2. Okay, and so do we do the other one? If the difference is less than 3, so 5 minus 1 is 4, so we do it. 5 minus 3 is, hold on. if the so we're not thinking about the modulo, we're thinking about the difference between this, but that would be the modulo, right? So obviously I can look at the test cases, but I'm trying not to do this. I'm trying to make sure that I am seeing and looking at the reading comprehension part. So if the difference between the grade and the next multiple of 5, so here is less than 3, less but not inclusive. So let's something and then 5, okay, well that's a thing of 0 and I don't need to round, okay? This one, and it's 4, and so the difference between here and here is going to be 1, so that is less than 3. 1 is less than 3, okay? So that was at 4. Now at 3, right, that's going to be 2 here, okay, which is less than 3. But then when we have the 3 here, that is not less than 3. So we don't do it. So it should just be this. Otherwise, like this, right? And I need to say else here. LF. Okay. Return result. Kind of like that. Let's see if we got any egregious errors. Okay. Okay, there we go. Awesome. Now a little button is going to pop up somewhere. It says continue. Okay. Woo! Continue. Come on. Next challenge. So, Sam's house has an apple tree and an orange tree that yield an abundance of fruit. Okay? Using the information given below, determine the number of apples and oranges that land on Sam's house. Okay? In the diagram below, the red region denotes the house where S or delta, okay, is the start point, okay, and T is the end point, start point, okay, start and stop essentially, is the end point. The apple tree is to the left of the house, okay. Where am I? To the left of the house, and the orange tree is to the right, okay? Assume that the trees are located on a single point where the apple tree is at point A and the orange tree is at point B, okay? So I think it's meaning we don't need to really consider that this tree has diameter. It's just condensed to this point here, A, and this is condensed to this point B, okay? When the fruit falls from its tree, it lands d unit distance from its tree of origin along the x-axis. A negative value of d means that the fruit fell from d units to the left, and a positive d means towards the right. Okay, so if it's out here, so this one fell towards the right, so it would be positive units d, right? Okay, given the value of D for M apples and N oranges, determine how many apples and oranges will fall on Sam's house in the inclusive range S to T, okay? For example, Sam's house between S of 7 and T, if the apple tree is located at A equals 4 and the orange tree is at be 12. There are m equals 3 apples and n equals 3 oranges. Apples are thrown here, units distance, okay? Adding each apple distance to the position of the tree, it would land at here, right? I'm trying not to actually look at those because that's kind of, I think, the answer, right? So that's what we're going to have to think through. Complete the apple, okay, editor below. It should print the number of apples and oranges that land on Sam's house, each on a separate line. But it's going to be doing that okay, maybe we do have to do it in our function, not here. Whatever. Okay. The first line contains 2 spaces. Okay. Print 2 integers on 2 different lines. The first integer, the number of apples. Okay. Okay, whatever. So I'm gonna come here and we want to find, we're given S and T, okay, and then we're given A and B. So now I am going to say apples in range equals 0, oranges in range is equal to 0, okay. For apples, for apple in apples, okay. Now, what do I want to say? Apple tree is here, and I want to say if the distance is, so this is to the right, so if, and this should be an integer array, right? Apples, integer array distance at which the apples fall from the tree. Okay, so now if apple distance and this is positive, so plus A, which is the apple tree, is greater than S, okay, and apple distance plus A is less than T, we say apple in range plus equals 1, right? Same thing for distance in oranges if orange distance, okay, if orange distance, now this is going to be a negative number, but I still do plus B, right? And that's going to be my where it falls. So if that is greater than S and orange distance plus B. So if it's greater than S and less than T, oranges in range plus equals 1, okay? And then print apples in range, print oranges in range. Okay, so let me just go back over this code and see if this makes sense, right? Apple distance plus A, if that is less than S, if it is less than S, no, that's not the region we want. If it's greater than S, right? If it's greater than S, and apple distance plus A, apple distance plus A is less than T, is less than T, okay? Now this one, if orange distance is less than S, or sorry, is greater than S, that's this region, and less than T here, okay? I think that's accurate. Let's, I should have done run, but okay, so we got that wrong. Interesting. Why would this be the case? Expected 1, expected 1. Does it say what I gave? Okay. What is it happy with? What is it? Compiler message. It just says wrong answer. Let's press run code and just see what it's angry with. My output is 0 and 1. Okay. It expects 1 and 1. But we went over this and I thought I got it right. So this one right here, apple distance plus A, right? And A is going to be where I currently am. So if where I currently am plus how far it falls, and to the right is positive, okay? If it is greater than S, this region, and is less than T. The only other thing that I can think of, hold on, is it said inclusive somewhere, right? Like, I don't know. Let me just see if this is. Could that be a problem? Okay, it was inclusive. So it's like, I thought that my range is... Okay, good. Reality is still here. Okay. Awesome. Okay, so you are choreographing a circus show with various animals. Okay. For one act, you are given 2 kangaroos on a number line, ready to jump in the positive direction, okay? Towards positive infinity. The first kangaroo starts at location x1 and moves at a rate of v1 meters per jump, okay? I feel like I'm back in like physics class. The second kangaroo starts at location x2 and moves at a rate of v2. When are they going to meet? At what time t do they meet? Okay. You have to figure out a way to get both kangaroos at the same location at the same time. At the same time. As part of the show. If it's possible, return yes, otherwise return no. Okay. After one jump, they both move forward. This. So the answer is yes. Okay. Complete the function kangaroos in the editor below. Returns yes or no. Okay. So we have x1 and v1. x2 and v2. So x1 starts at a location here and moves at this rate, okay, per jump. And each one jumps at the same time, right? So ding, 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 ding. Are they ever going to meet up? So, okay. At the same, part of the same show. So, there's two questions, kind of. Let's imagine that one is going faster, right? Like, let's say that the one ahead of it is faster. And so we jump one time, but let's say when we jump, this one jumps much further. And so they're never going to meet, okay? The other one is, let's say that this one jumps really far, and this one jumps very little. And it goes like this, watch. This one jump, and this is one jump. Did they meet? Is the question asking, do they come to the same location on a singular jump? Or is it saying, like, do they cross over? Does that make sense? I'm gonna take it same place at the same time, as meaning their jump needs to hit the same place. So what I'm gonna do is I'm gonna say if x1 is less than x2 and v1 is less than v2, return, I need to print no return. Likewise, if x2 is less than x1 and v2 is less than v1, print no and return. Okay, now I guess I could have captured this in the actual thing, because I also need to say so if I still need to do this, like x let's see. So I'm going to say if x1 is greater than x2, kind of like this, while x1 is greater than x2. So once they cross over, then we want to stop this loop. So I'm going to say, like, if x1 is equal to x2, then we print yes and return. Otherwise, I do x1 is equal to x1 plus v1, and then we say x2 is equal to x2 plus v2, kind of like this, right? And then we keep doing that. If this ever terminates, we print no, okay, and return. Okay. So now, if x1 is less than x2, in this case we want to do a while loop. Same idea, x1 is less than x2. So while this is true, we are going to say if x1 is equal to x2, then we got to the jump together. Okay, so print yes like this and return like that. Not like that, but like that. Okay, so now I want to move them. So x1 is equal, I can just say plus equals v1, and then x2 plus equals v2 like this. And if this ever terminates, we print no and return. Okay. So we can do this and get all of them wrong. So that good. Good. I was just testing it. I just wanted to make sure that it was wrong. I just wanted to make sure that the compiler was working, you know. That's what I was doing. Runtime error. Why is this? Expected output is yes. What did I give? So why are we angry? Why are we angry? Okay. Supported for type none. Okay. What's going on here? Kangaroo. Okay. Here. Okay. So apparently we just. Okay, hold on. So. Oh, I do need to change this to make sure that it says equal to. So we want to keep running even when it's equal to, right? Okay, but a string, so it returns a string. Okay, fine. No, return no. Copy this. Return no. Return no. Return no. Return yes. Yes. Get rid of you. and get rid of you. Ah, now we're looking better, see? I told you I was just testing it. I just want to make sure that it was catching my... Yeah. Wait, did I press submit or what? What? Why? What's going on? Submit. Submit 情况. Run. Well, we passed the run case, but I don't know what's going on with this submit. Do I have... Maybe I lost internet? That happens a lot, actually, is I lose internet. I'm going to take a sip of water while this maybe... I don't know. Okay, there we go. There we go. So I think I lost internet for a little bit. That happens a lot. Although test case 10... Ah! Test case 10 fails. Why? Time limit exceeded. Interesting. Why would this... Is there an optimization I can do? I can't... I don't know. And I don't think it's very helpful for me just to spin my wheel. So let's go right to Gemini and see if we are missing something. To hacker. Okay. This is a kangaroo problem. Okay. Algebraic logic, simulation. Sound, it can be risky in competitive programming. I don't want to be a competitor. I just want to get it. I just want to be a software engineer. Okay, if the kangaroos never meet, but jumping forever, your code could run out of time. But I thought I... Hold on. Let's take if they're equal to each other, right? Say that they're equal to each other. If x2 should it be like this though, are equal to each other, right? Then we come in here because I want to get this case here. But I already check if their velocities are wrong. So like if x2 is behind me and... Or, sorry, if x1 is behind me and he's slower than me, then you can't do it. If I am behind x1, okay, and I'm slower than x1, then I can't do it. Why would that one fail though? To realize is that it's actually a math problem in disguise. Imagine two lines on a graph, yeah. For them to meet, the line must be there, okay. Infinite loop. If v1 equals v2, but x1 does not equal x2, they might jump at the exact same speed and never meet. Okay, I should have I need to do that extra test case. So, the velocities are also equal to each other, right? If the velocities are equal to each other, yeah, it should be like that. Because I say I'm behind, but I have the same speed as you, so that's not gonna happen. Okay. Now, how is it saying to solve it? Non-integer time. The kangaroos only land at the integer steps of here if they pass each other in midair but never land at the same spot. The math way optimal. Instead of jumping millions of times, we can just check two conditions. Speed check. If the kangaroo starts behind, if not, it will never catch up. Modulo check. If the distance between them is perfectly divisible by the difference of their speeds. Okay, so good that it's doing it. More modulo. Today we've gotten a fair amount of these kind of like questions on HackerRank. Okay, fine. Using the formula here, so x2 minus x1. So the difference in their positions, their starting positions, modulo the difference in their speed. That equals to 0. If the one behind, so is it assumed that V1 is always behind? Whatever, fine. I would have to think about that for a little bit, a couple seconds. Well, not a couple seconds, or else I would do it right now. Okay, fine. Are we gonna get another one? Or is it going to be like a... Okay, let's see what we're doing here. There will be two arrays of integers. Determine all integers that satisfy... What time is it? It's almost midnight. That's fine, whatever. Determine all integers that satisfy the following two conditions. The element of the first array are all factors of the integer being considered. The elements of the first array are all the factors of the integer being considered. The integer being considered is a factor of all elements of the second array. These numbers are referred to as being between two arrays. Determine how many such numbers exist. What? Okay. Example is 2 and 6, B is 24 and 36. There are two numbers between arrays 6 and 12. Between the arrays. complete the get total x function in the editor below, it should return the number of integers that are between the two sets. Get total has the following parameters. Returns the number of integers that are between the sets. There will be two arrays of integers. Determine all integers that satisfy the following two conditions. Number one, the elements of the first array, okay, are all factors of the integer being considered. I mean, this 24? I don't know. What is integer being considered? What is that supposed to mean? Okay, the integer being considered is a factor of all the elements of the second array. There are two numbers between the array 6 and 12. Six modulo 2 and 6 modulo 6 is 0. 24 modulo 6 is 0. 36 modulo 6 is 0 for the first value. Okay, see, this is what I mean, like, normally on leak code questions, I never get to the point where I don't even understand what the question is asking. I can normally figure out what the question is asking. On HackerRank, I'm to the point I'm looking at this, I don't even know what it's asking me to do. I don't know what any of this means. Complete the total. Determine how many such numbers exist. Okay, so what we're going to do is we're going to come here and we're going to copy and paste this. Okay. And we're going to paste this into Gemini and see what it has to say about this. I can't even understand what this question is asking me. How can I analyze this question to improve my reading comprehension of these kinds of questions and figure out what algorithm I should use? Okay, let's see what it has to say about this. And I think I'm out of water. That's unfortunate. Math-heavy language that makes simple concepts sound intimidating. To improve your comprehension and algorithmic choice, let's break down into repeatable systems. So, how to analyze the question, translation step. When a question feels like a word salad, target number and arrays. So, condition 1, elements of A are factors of X. Translation, X must be a multiple of every number in A. Okay. Key math term. X is a common multiple. Okay. X is a common multiple. X is a factor of all elements of B. Multiple and factors, okay? Well, here's another thing, like, okay, I remember doing multiples or I remember doing factors and all of that, like, whatever in algebra. It's like, okay. So maybe I need to go back and relook at some of my, like, basic algebra or something. I don't know. Again, like, these kinds of questions are not asked on LeetCode, so it's like, this is exactly what I'm trying to do, which is find those different types of questions that are asked here on HackerRank and see that difference in things. Okay, so I'm gonna come here, and between two sets, do I have the ones that I've solved? So what is debugging, NP problems, recursion, bit manipulation, constructive arrays, dynamic programming, greedy, graph theory, search, sorting strings. So this one here is in implementation, okay? So problem algorithms, data structure, right? And we have solve challenge. Does this mean that all of them are going to be within this kind of like implementation component? Let's see, prepare. I'm just looking around to kind of understand this a little bit more. So we have the problem solving, right? Okay. What is this? What does start preparation mean? Mock tests, mock interviews, graphs. Do they give the actual problem that we can... Okay, so they do give this. So we can also come here a little bit. We can come here and do these ones as well. Okay. So right now, I'm just trying to figure out, like, okay, well, what is here on HackerRank? Because we are still very new to HackerRank and trying to understand this. So I did, what, like problem solving? And it's just called problem solving, okay? And it just was here, right? And now this is no longer highlighted. Let me highlight it and see what it says, right? Did it change anything? Breaking records. It looks like it is the same thing, right? Yeah, they're all this, like, problem solving implementation, okay? So I'm going to come back to Gemini, and with that updated information, I'm going to ask it, like, what is problem solving and what is implementation, and what are some concepts that I can look up to kind of see how other people are doing these types of questions. Like, are there LeetCode questions which correlate to that? Let me actually go to LeetCode itself and problems. Is there something here that maybe one of these, because right, there's a lot of here of things in here. Oh good, I can highlight this. Okay, maybe it would be something like number theory, counting possibly. I haven't done a lot of counting actually. That's another gap in my knowledge. I need to fix that as well. I don't know, I haven't done much prefix sum. I haven't looked at bit manipulation. I've done a lot of like following the neat code map. Okay. Well, okay, so come here. I'm going to finish reading this, then ask that follow-up question. Okay, so the goal, find how many numbers x are simultaneously a multiple of everything in A and a divisor of everything in B. Okay. A multiple of everything in A and a divisor of everything in B. I need to think about this. How to visualize the search range. To find an algorithm, you need to know where to look. The smallest x could possibly be is the largest number in A, because x must be a multiple of it. The largest number in x could possibly be... See, like, I know if I... if I understood what they were talking about, that this would just be, like, flow logically, right? Like, well, of course that's going to be the case, but it's that reading comprehension thing about, like, oh, okay, this is... what are we even talking about right now? An example, 2, 4, and 16, 32, and 96. We only need to check numbers between 4 and 16. Okay, choosing an algorithm. There are two ways to approach this based on the constraints. The brute force, since the constraints are small, you can iterate. You can loop through the range and check every number. Find the max of A and the mid of B. Jeez. Strategy to improve the reading comprehension. Okay. Divide, rewrite the sentences, draw a number line. Okay. Number theory, which actually, that was what we saw, right? I said number theory. Where was it? So we have combinatorics, which is like combinations and permutations, right? I hate that, which means I need to study it, right? Like if I feel uncomfortable towards something, it means that I don't understand it enough. So I have a bad feeling towards combinatorics from like long time ago in university. I remember that I was like, oh, I didn't like that topic. I can't remember why I didn't like that topic, but because I have this feeling, I need to go study it. That means that there's something in my, that I'm not, that didn't settle into my brain, and I need to face whatever I feel uncomfortable with is exactly what I need to face, right? So I need to do that, but I thought I saw number theory. I'm probably going to go for a walk pretty soon because my brain is very foggy right now. Oh, come on. I know that I saw it. Let me copy this. Maybe it's the blue. That's why. Okay. So it's going to be here somewhere. Number theory. Here it is. Number theory. Okay. So it's saying number theory, right? On HackerRank, it is in a section called problem solving and implementations, okay? And implementations, okay? I am trying to find out what this might be grouped as. You are mentioning number theory, and I see this as a, okay, so we lost internet again, and I see this as a topic in Leet code. Are there other key words which I can search to find, to become more familiar with questions in what was it? It was called like basic problem, like just problem solving, okay? What is search? I want to know what search means. Oh, because we don't have internet? Yeah, okay, fine. I want to find out what, like, search is. What does that mean? Okay, come on. In this group of questions on HackerRank, will all of them be... my goodness, I'm not even going to fix this typing. Will be number theory questions. Okay. Oh, but we don't have internet, so it's not going to take it. Okay. Well, okay. Oh, okay. Let's see. Should we wait it out or what? I don't know. Let me pause it and then see if I can fix the internet. Alright, so I reset things. Now we'll see if it takes it. It's loading up, I think. Or resetting right now. So anyways, I think what I'm going to do is I'm going to ask this question. I'm going to try to find out some groups that I can like type into YouTube and watch some videos like right after I'm done with this. Maybe I go for a walk first. Go for a walk, clear my mind, then come back, watch some videos, try to understand it, and then come back to more of these problems. So I think that's what I'm going to do. So I'm going to press go here, right? But I'm curious to, so I want to see what the other ones are. Like search, right? Like what does search mean? Oh, but okay, fine. But is this like binary search or like what's going on here? Search, come on. Oh, come on. Okay, fine. Okay, so I have internet again. So this one is just problem solving, and now this says problem solving like data structures, and these ones are like different questions. Oh, because now it's loading up search. Is that right? Are all of these search? Grid, land, metro, ice cream parlor. This says just problem solving. I'm not sure what problem solving means. Like, what does problem solving mean? Is everything problem solving? Or is it, like, does that mean the topic? I'm not sure. I'm going to click this one just to see what it says, right? Okay, so it does say search right there, okay? So, two friends like to pool their money and go to the ice cream parlor. They always choose two distinct flavors and they spend all of their money, okay? Given a list of prices for the ice cream flavors, select the two that will cost all the money that they have, okay? Interesting. Okay, before I get too much into this, I want to come back and read this. And implementation selection is a bit of a catch-all category. It essentially means the logic is straightforward. Now show us you can write the code to handle the steps. Okay. However, you are right to notice that many of these have mathematical undercurrent. If you want to find more questions like this and improve your vocabulary for these patterns, here are some keywords that you should look for. Is number theory. This covers anything involving factors, multiple prime numbers, greatest common denominator, greatest common divisor, okay, least common multiple between two sets. Problem is a classic number theories problem, okay. Divisibility, look for this keyword. Problems in this group usually ask you to find numbers that satisfy certain division rules, like kangaroo problem. Wow, we saw that one. Or between two sets. Okay. Modular arithmetic. This is a fancy way of saying problems that involve the modulo. Yeah, again, back to that thing of what am I scared of and what don't I like? I don't like the modulo. And trying to figure out these algebraic little questions. I don't like the algebraic little questions. Brute force and exhaustive search. This is the algorithm used when you check every number in a range, trying every possible until one works. Like, realistically, this is probably what I'm going to be shooting for if I get one of these type of little algebraic questions. Right, like, okay, so if you want to become fluent in these type of questions, search for concepts like greatest common divisor, sieve, and arithmesis. Okay, the fastest way to find all prime numbers. Relative prime to, oh my goodness, okay, checking, will they all be number theory? No, HackerRank's implementation section includes simulation, okay, like the kangaroo one that we just did, array manipulations, problem that have you rotate, flip, or filter lists of data based on specific rules, string parsing, okay. Okay, so simulations and array manipulations and string parsing. Okay. How to classify a question when you see it. Am I looking for a specific number in a range? If so, divisibility, number theory. Am I following a set of instructions? That's simulation. Am I counting occurrences of something? Hash map and frequency. Okay. A tip for your comprehension. The reason between two sets feels confusing is that it uses passive voice. Elements are factors of the integer. Okay, whenever you see a math-heavy sentence, try to flip it to active voice. So passive, elements of A are factors of X. Active, X is a multiple of all numbers in A. Okay, active, passive voice. Okay. Yeah, back to things that are important to know about, but I know about the concept, right? But it's something that I haven't thought about in years, and I can't even remember when I was doing it, like, whatever, in, I don't know, not grade school, but like high school maybe. That's something that you hear about, but you don't pay too much attention to, right? So it's like, okay, fine. It's coming back up, which means it's important. Once again, the things that you don't want to, or that, like, maybe you suppressed within your subconscious of, like, oh, I don't want to learn. Not, I don't want to learn about that, but you're, like, scared to learn about. It's those things that, you know, you try to brush under the rug. But that's why I'm doing these HackerRank problems as opposed to just continuing with the LeetCode, code, because I'm trying to find those things that, you know, gremlins in the walls kind of thing. Okay. Alright, simulation, number theory, and GCD, and LCM. So that's what I'm going to look up. And then in the next video, what I think I'm going to do is I'm going to come back and I'm going to do more of these kind of questions. And we will come here and we'll do more problem solving, right? And then we'll also do more of just the different kind of questions. Maybe we'll do searching, right? Maybe we'll do graph theory. I don't know what we'll do, but we're gonna keep doing some HackerRank questions. And yeah, so if you are interested, subscribe. I would love to have you come along for the journey with me. Thanks for watching. My name is Timothy Lee Grant, and I'll see you guys in the next video. So.